Now we're looking at Module 8, Lesson 2, and again we're looking at ionic versus covalent things, but this time we're looking specifically at writing their names and their formulas. So as we look here for just a minute, part of the question is going to be, how do I tell the difference? If I have all these formulas mixed up, how do I know which way to name them? Well, first of all, when you're looking at these, you need to realize that ionic compounds, let me find my mouse here somewhere. Ionic compounds are made of a metal and a nonmetal. Oh my goodness, it's writing all over the place. They're made of a metal and a nonmetal. And so if you are looking at their formulas, look at the very first ingredient and decide if it's a metal or a nonmetal. Ionic compounds, they have parentheses, usually around something in the, well, not usually, but they oftentimes have parentheses around something in the formula. If you have a polyatomic ion, you will never see the parentheses, at least in what we'll do in the covalent compounds. Hydrogen for ionic compounds is written first with a nonmetal on the right side. It can be written on the second side, but it has to have a metal to the left of it. So what I'm trying to tell you here is if you see something like this, like LiH, when I see Li first, that's a metal, then I know that this is an ionic compound and hydrogen is acting as a nonmetal. Okay, if I see this, I also know that this is an ionic compound because the hydrogen is written first. It's written over here on the left-hand side. Oops. And its placement tells me that it's acting as a positive ion. So it's acting here as H+, and here it's acting as H-. Okay. Covalent compounds, they'll have two or more nonmetals, and the hydrogen will almost always be on the right side. The difference is, instead of it being written with like a metal, as in this one, it'll be written with a nonmetal. And you have a nonmetal. Remember I told you that hydrogen on the right side is acting as a nonmetal. Well, then if it's a nonmetal with a nonmetal, that's going to make it covalent. So I have some examples here for us. So to go further with the naming as well, for ionic, you're simply going to name the ions. You do not use prefixes, and they're going to end in either IDE if it's an element off the table, or ate or ide if you have a polyatomic ion. For covalents, we're going to use the prefixes, and they're always going to end in ide. Right? For the formulas, ionic has to be reduced to the lowest whole number ratio. So remember, if you have something like Mg and O, if you accidentally do it this way, MgO2, that is not correct because those can both be reduced down to 1 and 1. And remember, with covalent, you do not have to have them reduced. Like, this is perfectly acceptable and you're not breaking any rules whatsoever. So here's some naming examples. All right, so when I look at this one, what I'm going to have to ask myself each time is it ionic or is it covalent? Your first practice set, I'm going to have you identify if it's ionic or covalent and then name them accordingly. I look here and I see magnesium. Magnesium is a metal. So that means this is ionic, and I'm not going to use any prefixes. I'm just simply going to name the first element, which is magnesium. The second element is going to end in IDE. Magnesium is also not one of the things that requires a Roman numeral. You're also going to have to keep that in mind. Like, we're still playing by all the old rules. We're just kind of throwing it all up together here in one big bunch. Magnesium is not a transition element, and it's not one of my exceptions. So magnesium chloride is going to be the name. All right, for the second example, I see carbon at the beginning. That's a nonmetal. So this is going to be covalent, which means I need to use the prefixes. The first one does not get a prefix, so we just simply write carbon. The second one gets a prefix. There's 4. The prefix for 4 is tetra. And then we change the endings of almost all of these to ide. So we're going to put chloride. All right. This one, sulfur's first. Well, sulfur is also a nonmetal. So this is also going to be a covalent compound. I'm going to use prefixes. I do not put the mono prefix on the first one, so I just write sulfur. And again, there's 4. And again, it happens to be chlorine, so sulfur tetrachloride. On the next one, sodium. Sodium is a metal. I know because if I look at the periodic table, it's way on the left-hand side. So that's going to be ionic. So I don't want any of the prefixes. So I just simply name my two elements, sodium, and then oxygen would get switched to oxide. This one, all right, carbon. Carbon's a nonmetal, so I'm going with the covalent naming. I need prefixes, so we're going to put carbon, and then we need to use the prefix again. This one's tetra, and we'll change hydrogen to hydride, carbon tetrahydride. The next one, Ba is a metal. Barium is to the left of the stair steps. So this is going to be ionic. I don't want any prefixes. I write barium, and then the second one is sulfur, so I simply write sulfide. All right. This one, boron. Now, boron is a metalloid. And I told you earlier that metalloids typically act as nonmetals. So if that acts as a nonmetal and it's actually with another metalloid, then we're going to treat this as a covalent compound. This time I do need to use a prefix because there's not one of the first thing. The prefix for 2 is di, so diboron. And then silicon would change, oh, I forgot the mono part. We'll just scratch that out, it'll be faster. Monosilicide. Okay, this one. Now, be careful because I do see that this is a nonmetal, but I also recognize this whole thing right here as a polyatomic ion. We have something else that tells me that I need to be careful is we have not named any covalent compounds with 3 letters in them. Like we have not had 3 elements. Everything has had 2 words. We've all done what's called binary compounds. That means it's made up of 2 ingredients. So this would not be nitrogen tetrahydrogen or tetrahydride monochloride. Like that's too many names. So bells and warning whistles should be going off in my head. This right here is a polyatomic ion. It's a positive polyatomic ion. So this is an ionic compound. We just named the ions. The first ion is called ammonium, and the second ion is chlorine. We're going to change it to chloride. So ammonium chloride. Last but not least is this one. Now this is just plain old N. There's 2 ingredients, so this is covalent, and there's only one. So on our first one, we're simply going to name the nitrogen, and then we'll use the prefix tri for the fluorine and change fluorine to fluoride. Okay, whew, that's a lot, right? I think this is the hardest part for students is keeping these straight because people want to start throwing prefixes and everything and want to forget about all of it. Now, if you listen to what I just did, I went through the thought process that you need to be going through as you do this. You need to be asking yourself, is this a metal or is it a nonmetal? If it's a metal, then I don't use the prefixes. If it's a nonmetal, then I do use the prefixes. And as I did these for you, I do realize I didn't include anything in here that has any of our exceptions in it. So don't forget, if you come across something like this, like SNO, and I look at it and I go, okay, this is tin, it's a metal, so this is ionic. Remember, tin is one of your exceptions. Tin needs a Roman numeral, and I still need to do that. That's with us forevermore. This is going to be called tin something oxide. And what you learned before was to work backwards and to look at it and go, okay, I don't know tin's charge, but I know that oxygen is a -2. There's 1 tin there, so that 1 tin had to be a +2 in order to cancel it out, because remember, that's a rule. They have to go together in such a way as to cancel each other out. So this would properly be called tin 2 oxide. The same thing goes of, remember tin and lead were your 2 exceptions that had to have Roman numerals. And remember that you had silver, which was a +1. You had cadmium, which was a +2. And you had zinc, which was a +2 that you had to remember. So if you are given one of those, like if you're given AgCl, you would just simply name that silver chloride. You would not give a Roman numeral because it is something that you had to memorize. So don't forget about those exceptions. You had tin and lead that need a Roman numeral, and you had silver, cadmium, and zinc, which did not. Now, something I think that you will find to be easier is the writing of the formulas, because they're already done. Like the prefixes, you don't have to worry about it, it's already there. So how would we write hydrogen monoiodide? Hydrogen. And then when I see the mono, I know that this is a covalent compound because covalent uses the prefixes. So monoiodide would just be HI. Sodium chlorate. Well, it's the same thing we've been doing before. And I can do a little work here for you to remind you. Sodium has a +1 charge. Remember, if it ends in ate or ite, I don't have any of those on here, ATE or ITE, you need to go to your polyatomic ion tables. Chlorate is ClO3 -1. They cancel each other out with one of each. So my final formula is NaClO3. Okay. Iodine pentafluoride, I'll see the penta part. I don't need to do any of this work. It is covalent, so I just write it. Iodine is I, pentafluoride, that's 5 Fs. I like these so much, it's so easy. Those are done. Magnesium nitride. Okay, I see no prefixes, which means I need to do the math work. Magnesium is Mg. It's a +2 using the periodic table. Nitride is a -3. That does not balance out. If you do the balancing, it will take 3 magnesiums and 2 nitrogens. This will be your final formula. Dinitrogen trioxide. I see prefixes. No math work for me. This is covalent. Dinitrogen is N2. Tri is 3 oxygens. Boom. Done. Phosphorus triiodide. We're in luck again. No math work. Phosphorus, there's no prefix mentions. That means it has to be 1. Triiodide would be 3 I's. Lithium hydroxide. I don't see any prefixes, so it means we've got math to do. Lithium is a +1 using the periodic table, and hydroxide is a polyatomic ion. If you look it up, it's 1 negative. So that means 1 + 1 negative. They cancel each other out already. Our final formula is LiOH. Ammonium sulfate. First of all, I recognize ammonium as a polyatomic ion, and sulfate ends in 8. That's a polyatomic ion. This has to be ionic. So when you look them up, you have NH4, which is a +1. Sulfate is a -2. The only way to make them balance is to have 2 of the NH4s. So don't forget we need parentheses for anything that you have more than one of. There would be our final formula, NH42, that shows there's 2 of those, and 1 of the SO4s. The last but not least is calcium carbide. I see no prefixes, so this is ionic. Calcium is a +2. Carbide is a -4. Okay, they do not add up to 0, but if I have 2 calciums, that'll be a +4. So I need to have 2 of those. Ca2C would be my final formula. So hopefully you saw what I did as I went through there. I was looking for the prefixes. If I see no prefixes, I've got math to do. And if I see prefixes, then it's pretty easy. Just follow through with those and write your formulas. So of course, what do I have is some practice for you with doing this. I've judged my amount of practice based on what it takes in face-to-face classes for people to more or less get the hang of this. So I have a couple different things for you to do. The first practice involves having you identify outright if it's ionic or covalent, and then I take away the help as we go. I've also included some additional problems that some of you may find beneficial, but it's not mandatory. So be sure to read the instructions and to look at the due date so that you know what is expected of you. All right, go to practice.